Good morning students. Today in this video we will discuss our chapter 12, that is friction. Okay. So before entering into this chapter, let me ask you a few questions. Okay. Why you need to apply brakes to stop a moving bicycle? Or why you slip when you step over a banana peel? And why it is difficult to walk on a wet floor? So you have to answer me these questions after completion of this chapter. Okay. Okay students, now we will discuss about force of friction. Okay. At first, let us know what is friction. Friction is the force that is responsible for stopping a moving object. Okay. Now, a force of friction always work on opposite direction. So this one we have already studied in the previous chapter, is not it? So there is a short video for you which will help you to understand that a force of friction always work on opposite direction. If I apply force from right side, the book will stop at a point. Here the force of friction is acting from left side. Now if I apply force from left side, the book moves at a point and it stops there. Here the force of friction is acting from right side. So in both the cases the force stops. So in both the cases the force of friction stops the book. So students, from this video we came to know that if we apply force from right side, the force of friction will act from left side. And if we apply force from left side, the force of friction will act from right side. So is it clear about force of friction? Okay students, now let us know what causes friction. What is the cause of friction? You see a surface, it may look smooth, okay, but there are many irregularities like this, okay. So these irregularities are more in rough surface as compared to smooth surface. That is the reason why there is more friction in rough surface like sand. You are not able to ride bicycle on sand. Do you know why? Because of these irregularities. Now what happens, you see, when we keep an object over the surface, okay, suppose this is surface 1. If we keep an object over the surface, it interlocks itself with the surface like this. Now, to break this interlocking, we need to apply force. Okay, that is the reason why friction occurs. Friction occurs because of interlocking of surface and object. Okay. Now, let me tell you what are the factors that affect friction. So the first one is smoothness or roughness of a surface. If the surface is smooth, the irregularities will be less. As a result, the friction will be less. Okay. Suppose a smooth surface. This is a smooth surface, and here the irregularities are very less. So that what happens? We need to apply less force in it. Is not it? To make an object move. On the other hand, if the surface is rough like this, what happens? There will be more irregularities. Let me give you one example. You push a ball in a ground, okay, and you push the same ball in a marble floor, where the ball will move fast, okay. If you push a ball in a marble floor with the same force, it will go to a very long distance. On the other hand, if you push the same ball in the ground with the same force, what happens? It will go to a very short distance. Why? Because then the irregularities are more as compared to smooth surface. Okay? Now you see, friction depends on the mass of an object also. If the mass of an object is heavy, means what will happen? Suppose this is the surface and mass of object is heavy. It will press the surface. It's not it. As a result, the interlocking will be more. And to break this interlocking, we need to apply more force. That is the reason if you keep a book on a table and a ball, and if you apply same force on both the object, which will move fast, the ball will move fast because it is lighter. On the other hand, the book, okay, which is heavier, will move to a very short distance because the friction will become more due to the heavy weight. Okay students, now we will discuss about types of friction. What are different types of friction? Okay.
Did you notice something in the animation you have just seen? In which case was it more difficult for the person to move the bag? When the bag was at rest, wasn't it? Why do you think it's always hard to move a static object than the object already in motion? You already know that friction occurs because of the unevenness of an object's surface. As one object slides over the other, their irregularities get interlocked into each other. So, to move an object, you have to overcome this interlocking. The amount of force required to just about move this static object gives a measure of its static friction. But when the object is already moving, there isn't enough time for the irregularities to lock into each other. That's why the force of friction in this case is less than the static friction. Such a friction caused by an object in motion is called sliding friction. If you recall the earlier animation, you would have noticed that once the person attached wheels to the bag moved quite easily. Why was that so? Look at the surface area where the wheel touches the ground. As the wheel rolls, the surface area in contact with the ground moves up, even as its adjacent surface area moves down toward the ground. In this case, less force is required to overcome the interlocking of the two surfaces. The interlocking instead is helpful as it prevents the wheel from slipping. The friction generated during such a motion is called rolling friction. That's why the force of rolling friction is less than that of sliding friction, which is less than that of static friction.
So far we discussed about types of friction. Now we will discuss friction is necessary evil. Means sometimes it is good for us and sometimes it is bad for us. So I will play the video so it will be easier for you to understand about this.
We know that friction is a force that opposes the motion between two surfaces. Let us have a look at some real-life examples where we make use of the frictional force. The friction between your shoes and the ground helps you walk. If you compare an old shoe with a new one, you will see that the soles of the old shoes are worn out and generally look flat and smooth. On the other hand, soles of the new shoes are grooved. Hence, the friction is greater between the new shoe and the ground. This improves the grip and prevents slippage. The friction between the tires of a vehicle and the road helps the vehicle move. The tires are threaded for increasing the grip of the tires on the road. You might have heard of bikes or cars skidding on wet roads. This often happens when the treads on the tires wear out and the friction is reduced. While riding a bicycle, if you want to stop, you need to apply the brakes. When you press the brake lever, the friction between the brake pads and the rim of the wheel makes the bicycle slow down and stop. So, is friction always useful? No, it can be a nuisance too. Friction can make it difficult for us to move things around. So what can we do to reduce friction? Add wheels. Rolling reduces friction and so it's easier than sliding. Now you know why it's easier to move bags with built-in wheels. Friction also causes wastage of energy in vehicles. When there is excess friction, we need more fuel to move the vehicle. So what can we do to reduce friction here? We could streamline the shape of the vehicle. If you think we sorted this problem out, there's another problem that friction poses. It wears things out. And how do we tackle this? In the case of machines, we can lubricate the parts that rub against each other. For this, we could use lubricants such as oil or grease to reduce the friction between the moving parts and make the movement smoother.
So students, these are the reasons why friction is considered as necessary evil. Okay?
From what we just saw, friction is a necessary evil. There are times when we need friction and there are times when we want to avoid it. So, we always need to reach a good compromise.
Okay students, now we will discuss about fluid friction. What is fluid friction? You see in science, gas and liquids comes under fluid, okay? And the friction caused by this gas and liquid are called what? Fluid friction, okay? So there is a short video which will help you to understand more about fluid friction.
Have you ever wondered why nature has provided birds and fishes with special shapes? They have streamlined bodies that help them move faster through air or water. Let's see how. Air and water are fluid mediums. When a bird moves through air, it has to push the air molecules that get in its way. The collision of these molecules with the moving bird causes friction. This fluid friction is called air resistance or aerodynamic drag. Similarly, fishes have to overcome the frictional force exerted by the water molecules in their way. This fluid friction is called hydrodynamic drag. Drag can be reduced if the object moving through the fluid has a streamlined shape. As birds and fishes have streamlined bodies, they easily push away the air or water molecules in their way, thus moving fast through the fluid medium. It's these birds and fishes that have inspired aircraft designers and submarine designers.
So why the body is streamlined, you see? In front, the surface area is very small, is not it? So in the previous chapter we learned that if the surface area is small, the pressure exerted will be more. As a result, when they hit the air molecule or water molecule, it will break easily. Okay, so this is the reason why birds and fishes have streamlined body. And in the same way, the aircrafts and submarines are also designed in the same way by inspiring from the nature. Okay.
The streamlined bodies of aircrafts and submarines reduce drag and thereby increase fuel efficiency. As we just saw, the shape of an object affects the friction it meets. Now, let's test some anchor designs for boats to see which shape helps to reduce drag. Click Drop Anchors to drop the anchors in the water. Carefully observe which shape overcomes the drag best and moves fastest. Why do you think the hemisphere landed first? The curved side of the hemisphere that moves downwards is more streamlined compared to the other shapes, so it gives the lowest drag.
So students, this is all about our chapter friction. If you have any doubt, you can ask me. Thank you and have a good day.